We discussed about how to design the circumferential lap joint for a boiler shell. So now we will consider one problem on that and we will discuss this one first, then we will move on to the next topic. So you first note down this problem, then we will discuss the solution. So after that we will go for the eccentrically loaded riveted joints. We will go to the topic. So first note down this. I'll give 5 minutes for you to note it down this one. It won't take much time. Then we'll go to the or we'll discuss about the solution also. So first note it down. So once it completed, just intimate me or inform me. A cylindrical pressure vessel with 1 meter inner diameter is subjected to internal stream pressure of 1.5 MPa. The parametric stresses for the cylinder plate and the rivets in tension, shear, compression are 80, 60 and 120 Newton per mm square respectively. The efficiency of the longitudinal joint can be taken as 80% for the purpose of calculating the plate thickness. The efficiency of the circumferential lap joint should be at least 62%. Design the circumferential lap joint, and calculate 1 thickness of the plate, 2 diameter of the rivets, 3 number of rivets, 4 pitch of rivets, 5 number of rows of rivets, and 6 overlap of the plate. Is it over? Hello? I think nobody is responding.
Yes, sir. అయిపోయింది సార్ లాస్ట్ కొంచెం.
ఓకే, నోట్ ఇట్ డౌన్. మీరు రెస్పాండ్ అయితే తెలిసేది అవుతుందా అవుతుందా లేదా ఎంతవరకు వచ్చిందని తెలిసేది.
అయింది సార్.
Okay, right. So now we'll see the solution. So here he has given he asked us design the circumferential lap joint. So in yesterday's class we have seen the design procedure for the circumferential lap joint. So in that, first two things, that is the thickness of the boiler shell and the diameter of the rivets, that will calculate it based on the longitudinal butt joint only. Then the third point, that is number of rivets, pitch of rivets, and number of rows of rivet and overlap. Only these three, 3, 4, 5, 6 only for this one. So first two comes from the lap joint only. Longitudinal butt joint only. So that's why he has given the efficiency of the longitudinal joint is also 80%, and the efficiency of the circumferential joint is 62%. Of course, he has given the values of allowable stresses in tension, shear, and compression also. The diameter of the boiler shell is 1 meter and the internal pressure is 1.5 MPa. So this is what first I read in what is the given data. So the given data is the diameter of the vessel is 1 meter, internal pressure is 1.5 MPa, efficiency of longitudinal joint is 80%, sigma T is 80 MPa, tau is 60 MPa, and sigma C is 120 MPa, and the efficiency of the circumferential joint is 62%. That is what he has given in the data. So now first we need to find out what is the thickness of the shell or thickness of the plate which is used to fabricate the boiler. So for that, this is the formula we are going to use. So whether it is a longitudinal joint or a circumferential joint, this is the formula we are going to use. T is equal to PA dA by 2 sigma T into eta plus corrosion alliance CA. So PA is 1.5, MPa is nothing but 1 Newton per meter square only, 1.5 into dA is 1 meter. We need to convert that one into mm. It is 1000 mm divided by 2 into allowable sigma T is given as 80, and efficiency of the longitudinal joint he has given it as 0.8 plus. Generally, we'll take corrosion alliance as 2 mm. So if I substitute and if I compute this value, which comes out as 13.72 mm. So therefore, we'll round it off this one to 14 mm. Thickness of the plate is, now it is 14 mm. So once we got the thickness, then based on the thickness value, we need to identify the diameter of the rivets. So here, the thickness of the plate is more than 8 mm. So therefore, you need to use Unwin's formula. That is, for diameter of the rivet, D is given by 6 root T. So that's what I written here. D is equal to 6 root T. T is 14. If I estimate that, I got it as 22.45. So now, from the data book, I will take the standard diameter for the rivet. If you look at the data book in the table 9.5, so you have standard diameter 24, and then you have 24 only. That's why I picked the value 24 from the data book. Then, so these two as usual. In case of longitudinal joint also, we'll do like this only. Then next comes the third one, number of rivets. First we'll estimate. Then based on the number of rivets, then we'll estimate how many number of rows are there. Then we try to find out if there are more than 2 rows or more than 1 row, we need to identify what is the transfer switch also. So then after that we need to find out what is the overlapping distance also. So for this, to find the number of rivets, so in the previous class we discussed that you need to equate the shearing strength of the rivets to the applied load or the force which is acting on these rivets. So that is the shearing strength of the rivets are, since it is a lap joint, all the rivets are in single shear. So your n is the, if n is the number of rivets, n into 5 by 4 d square tau is nothing but the shearing strength of the rivets. If you equate that one to the applied force, that is the cylinder is subjected to a longitudinal force of 5 by 4 into this capital dA square into internal pressure Pi. So if I rearrange the equation, I'll get the expression for n as Pi dA square by d square tau. So in this we know everything. So just I'll substitute these values into that expression. D just now we calculated here, calculated as 24. Then I'll get n is equal to 43.42. So I can't have a fraction number of rivets, and also generally we want to choose odd number of rivets. So the total number of rivets always will go for even number. So therefore, so this 45 I rounded up to 46. It's not mm. You don't have mm for number of rivets. You don't have any. It's only simply, it is only number. It is only a number 46. Number of rivets are going to be 46 only. So then we need to calculate the pitch of the rivets. So like we already discussed in the previous class, the pitch of the rivets is calculated based on the efficiency of the circumferential joint. So the formula for the efficiency of the circumferential joint is given it as 62% here. So based on that we can use that formula, that is eta 1 is equal to P1 minus D by P1, where P1 is nothing but your circumferential pitch. So D we already calculated, which is 24. So this is given the efficiency of the required efficiency for this circumferential joint is given it as 0.62. So then if I solve this equation, from this I'll get P1 is equal to 63.17 mm. So I rounded it up to nearest value, which is 64 mm. So once I got this pitch value, then I can find out the number of rows in a single row, or in one row how many number of rivets are there. So if I know that, based on that, so number of rivets in one rivet. So here I have total number of rivets. So total number of rivets divided by number of rivets in one row will get the number of rows. So to find that number of rivets in a row, I need to find out what is the circumferential distance. So then from that I can get the number of, okay, so before that, okay, here we got the pitch as 64 mm, but we need to test for that minimum and maximum criteria here also. The minimum value should be 2D, which is 48 mm, and the maximum value is CT is plus 41.28, where C is the constant value we need to pick for from the data book. So here for a lap joint having rivet, so 1.31, how I got it? So just you open our data book. So in that we'll see why I have taken the factor C as 1.31. So now open your data book and chapter number 9. Chapter 9. So in that we'll see why I have taken it is 1.31. So number of rivets per pitch length I'll consider as 1. So in case of lap joint it is 1.31 only. So if you look at the table 9.7 boiler core factor C, you can see that per pitch length. So initially what I am doing is I am considering there is only a one row. So one pitch length you have only one rivet. So for that you will get the C value as 1.31. So if you refer your table, which is in page number 9.19, so you can easily get that is 1.31. So thickness we estimated it as 40. So from this I got it as 59.62. But whatever pitch value we calculated, that P1 we computed here, we got it as 64. This one is more than your maximum pitch value. So P max maximum allowed pitch value is only 59.62, but we got it as 64 mm. So I cannot take the pitch value as 64 mm. So here, since the calculated value is more than this P max, I need to take this P max as my pitch value. So I taken the pitch value as, so since P1 is greater than P max, it is assumed that P1 is equal to 58 mm. So you can take any value. So no need to say that, or no need to think that why I have to take 58, why not 59? You can take 59 also, no issue. You can take any value which is close to this 59.62. You can take it. You can take 59.62 also as pitch value, no problem. But generally, we won't take fraction values. So that's why I taken a rounded value here. So once I got this pitch value, so that means we are readjusted the pitch value here. Earlier, using the calculation, using the efficiency of the joint, we got 64, but we adjusted this one into 58. So therefore, based on this pitch, again you need to readjust the number of rivets. So for that, the number of rivets in one row is given by, this is the relation. So number of rivets in one row is pi into di plus t by p1. So where pi into di plus t1 is nothing but the mean circumference of the boiler shell divided by the distance between two rivets. So then I'll get the number of rivets. So if I calculate this, what I got it is, I got it as 55. If I take this pitch as 58 and thickness we calculated as 14 and di is given as 1 meter, nothing but 1000 mm. If I compute that, it comes out as 55. But so this is what I'm saying, that there are number of rivets in one row is 55. But what is the total number of rivets I got from the previous calculation? The total number of rivets from this calculation I got only 46. See, I have only 46, the total number of 46 rivets, but here in my calculation I got in one row I should have 55 rivets. Is it possible? It is not possible, because I have from the based on that equation equating the shearing strength of the rivets to the applied load, I got only 46, but here this calculation, that means for this PI value I am getting a number of rivets as 55. Therefore what I need to do is, this cannot be satisfied, so I need to readjust this P1 value. Or else what I will do is, if I fix this P1 value, then what I will do is I will calculate the number of rivets required. Again, I will recalculate that. So therefore, the number of rows are given. Suppose if I take this one as 55 itself, then it is assumed that the type of joint. So that means only in one row there are 55, means there is only one row in the joint. So therefore, our joint type will be only single riveted lap joint only. Suppose here this N1 is less than our N what we calculated earlier, then you have more number of rows. But here it is, your N1 is more than N, so therefore definitely you should have only one row in your joint. So the revised rivet value, okay, now what we will do is, so by taking this N value is 55, now we need to readjust the diameter of the rivet. So that means again using the same equation here. So using this equation, now instead of N is equal to 46, now I will take N is equal to 55. So based on that, I will calculate what is this D value now. So that remodification we need to do that. So if we calculate that, you will get the diameter of the rivet as 22 mm. So if N is equal to 55, here if I take N is equal to 55, then the diameter of the rivet hole will become 22 mm. So once I done this, then so again if you want, you can recalculate your pitch value. Again it is interlinked here. So earlier by calculating the P1 value, what we did is we taken D is equal to 24, but now we got it as 22 only. So that means P1 minus 22 by P1. So you are going to get the smaller than the 64 or larger than the 64. You will get higher value only, because P1 remains same, but here you are, instead of minus 24 you have 2. That means if you substitute D is equal to 22 also, you will get P1 is more than your 63. So that means, so still it is violating that maximum pitch condition. So therefore I can stick to that P1 value is 58 only. So with that, now we design the pitch value, or we estimated the pitch value, we estimated the number of rows also there, and we estimated the number of rivets also. Number of rivets is 55 and pitch value is 58 mm, and there is only a single row in the joint. So the diameter of the rivet is 22 mm. So once you're done with all this, then the final thing is, since you have only one row, so there is no question of your transverse pitch. When there are more than one row, then only we'll talk about the transverse pitch. So here you have only one row, means your transverse pitch value is 0. So then only thing I need to calculate is, I need to calculate overlap of the plates. So for that, again to calculate this overlapping of the plates, you require margin. So margin is always 1.5 times the diameter of the rivet. So diameter of the rivet just now we computed, that is comes out as 22. So therefore margin is going to be 33. So if it is rounded off, so it is going to be 35 mm. Then A is going to be the overlap of the plates. So the formula for this overlap is PT plus 2M. So where PT is the transverse pitch, just now I said you don't have any transverse pitch. In case of a single riveted joint, it is going to be 0. So then your overlap is going to be 2M only. So that is going to be 70 mm. So like this, we need to design the joint. Once you design this, again you need to recheck whether this joint is now having that minimum required efficiency, that is 60% or 62% or not. You need to check that also. To check that, again you need to use the formula for the efficiency of the longitudinal joint, which is nothing but P1 minus D by P1. So 58 minus 22 by 58 comes out as 62.06. So in the question he has given that at least it should have 62%, means it is satisfying that condition. So then we can say that the design is safe, or the design is meeting the required efficiency criteria. So we'll stop at this point. So that means the design of the joint is over. Or else if you calculate here, if you get the efficiency is less than 62%, then what you need to do is you need to modify the P1 value. Accordingly, you need to modify D value such that your efficiency should be a minimum value of 62%. So like that, you need to proceed further to redesign the problem or to resolving the problem again. Okay, so this is how you can design a circumferential butt joint. So with this we completed the design of the boiler joints. So then next topic, we'll go on to the next topic, which is eccentrically loaded riveted joints. So what is eccentrically riveted loaded joint? So why we will call it as eccentrically loaded riveted joint. So here I have an example of for that eccentrically loaded riveted joint. Here I have some bracket kind of thing is there here. This bracket is riveted to some plate or something like this here through 4 rivets here. So this is one rivet and this is another rivet. Rivet number 2, rivet number 3 and rivet number 4. So it is that means these two, this bracket and this plate is connected through 4 rivets here. But the load is not acting directly on the rivet here. So it is acting somewhere here. The load is the force. F is applied somewhere here. So then in order to call this load an eccentrically load. So when we'll call a load is a eccentrically loaded load, if the line of action of that force is not passing through the center of CG of the object, then we will call that load as a eccentrically applied load or eccentrically loaded one. So here this is our joint. So now for the joint, if I compute the center of gravity, so here because of symmetry, obviously it is going to be the center of gravity is only at this location G. So now this has some offset distance, that is eccentricity is E, he has given here. So that means the load line of action of the load, this is the line of action of the load, that means the load is acting in this direction. Since this line of action of force having some eccentricity from the center of gravity, then we'll call it as a eccentrical load. Since this load is applied to this riveted joint, we'll call it as eccentrically loaded riveted joint. So now if you come across this kind of problems, how can I estimate how much diameter is required for this rivets? So that is nothing but design of this eccentrically loaded riveted joint. So now to design the diameter of these rivets, the first thing what should we know is what is the effect of this eccentrical load on these rivets. So that means what kind of loads it is going to create on these rivets. So based on that only I can design the diameter of the rivets. So for that, in the beginning classes we already discussed that. So whenever there is a eccentricity, so then about this point, if I take that, so what is its equivalence here? If I want to transfer this load to this plane, from this plane to this plane, what is its effect? Its effect is going to be a direct force whose magnitude is equal to F only, and in addition to that you have an additional moment. So what is that additional moment? The moment is nothing but this load multiplied by the eccentric distance. Here it is F into E. F into E going to be the moment value. So in which direction it is going to act? In the same direction as your applied load. So therefore you have two things. So that is P into F into E is the load moment and a direct force. So now if I look at from the rivet point of view here, is this load, this moment is going to be bending moment or twisting moment? I want to identify that. So any guess here what type of moment it is? Whether it is going to create a twisting moment or a bending moment in these rivets. So if I transfer this force to here, first of all, okay, if you have confusion again, what I'll do is I'll take this one as my x-axis and this one as y-axis. So what is the direction of your force? Direction of force is y direction. So it is acting along the y-axis. Of course, negative y-axis. And what is the direction of your offset distance? Offset distance is acting along x-axis. So about which axis the moment will be created? The moment will be created about z-axis. So mz is nothing but F into E. So force is in y direction and displacement is or distance is in x direction. So obviously your movement is about z-axis. So now if this is the x-axis and this is the y-axis, so your z-axis is going to be perpendicular to this xy axis. That we know. So now if this z-axis is the longitudinal axis of this rivet or it is perpendicular to the longitudinal axis, that I want to know here. So now you tell me what is the term? Z-axis is going to be the axis of the rivet or along the axis of the rivet or perpendicular to the axis of the rivet?
Along the axis, sir.
So because here you have shown the cross section here, the rivet length is in the z direction only. This is a plane. So how we can connect this plate to this this bracket to this plate? Through rivets only. So the length direction of the rivet is perpendicular to this plane only. That means along the z direction only. So that means if the moment is acting about about the longitudinal axis, then what we'll call this moment? We call this moment as a bending moment or twisting moment. Alla doubt akkada? Whether it is a bending moment or twisting moment? Sorry, I was class lo anta discuss chesam kada malli appude marchipotayatra meeru. Say I have a beam something like this. If it is subjected to force here, F, and this distance here it is. This is the longitudinal axis. So let us say this distance is A. F into A is a movement here. Is it a
bending moment, sir?
Is it a bending moment or twisting moment in this case?
Bending moment, sir.
Why a bending moment? So z-axis is something like this. Here the moment is acting about z-axis. Suppose if I take this one as x and this one as y, your moment is about the z-axis. Z-axis is perpendicular to the your longitudinal axis. Therefore, it is bending moment. So similarly, if I apply a force something like this in the z direction, if I have a force in the z direction, so again the same distance A. So if I take like that, then what type of movement it is going to create? Force is in z direction. So and your distance is in x direction. So movement is going to be about y-axis, right? So it is going to act about y-axis. So because of y-axis is subjected to bending moment or twisting moment. If the moment is acting about only x-axis, I will call it as twisting moment. Otherwise, if it is acting about z-axis or y-axis, it is going to be bending moment only. So why I am calling it as twisting moment? Because this axis is coinciding along with the longitudinal axis. That means if the movement is created about its longitudinal axis, we will call it as twisting moment. Otherwise, we will call it as a bending moment. So now come to this case now. So here this movement is along the longitudinal axis. So therefore, it is going to create this movement. Whatever movement is there, it is going to be twisting moment, not the bending moment. So that means this force at the center of gravity, if I transfer this force to the CG of the rivet, it is a direct force of F and a twisting force of magnitude F into E. F multiplied by E. So this is what we call it as twisting moment. It's not twisting force. I'll call it as twisting moment. So now I want to see that what is the effect of these two on the rivets now. So that means this force is there. This force will create what type of stress? And this what we can call it as twisting moment. This twisting moment is going to create what type of stress. So for that, first if I take this force, so this force is going to act at the center of gravity means I have a body something like this. So this bracket, it is supported at 4 locations here. It is supported at 4 locations and it is subjected to a force at the center exactly. So therefore, how it is these rivets are going to share this force? Since you have 4 rivets here, the total load is going to be whatever load you have, total load F, that force is equally shared by these 4 rivets because this force is applying at the center of gravity. So that means each rivet is at the same distance from the point of application of the load. So that means, so the effect of this load on each rivet is going to be same. So therefore, if I apply a total force of F, then each rivet will subjected to a force of F by N, where N is your number of rivets. If there are 4 rivets, I'll take it as 4. N is equal to 4. If there are 6 rivets, I'll take the number of rivets as 6. So then, whatever this force is there, I'll call this force as primary force. So I'll denote this one as P1. So that means, so this direct force will treat this direct force as a primary force. Why I am calling it as because of a primary force? Because you have another effect, that is twisting moment is there. So this will also create some sort of force on these rivets also. So for that, again, I'll find the magnitude of the force on the rivet because of the twisting moment also. Then I'll denote that one as a secondary force. So since I have 2 forces, the primary force is due to the direct force. So whatever force you are applying, because of the direct force, I'll call it as a primary force, and the magnitude of the direct force is F by N, where N is the number of rivets. So what type of force it is? Is it shear or it is a tensile force or compressive force? What type of force it is here? What type of force here? If I apply a force something like this, here, how this force is acting along the axis or perpendicular to the axis of the rivet? Right, just now we discussed this is the z axis. The axis of the rivet is along the z axis, right? So if I take like this, okay. So then, if the force is acting along this direction, z axis, then I can say it is a normal force. Then, if it is away from the body, I can call it as a tensile force. If it is towards the body, I can call it as compressive force. But here, your force is acting perpendicular to this, perpendicular to the longitudinal axis. So that means it is going to create a shear force. Something like you have a beam here. So this beam is subjected to vertical force. So because of this, what kind of force it is there in the beam? At any section of the point, you have a shear force. So therefore, this is a the direct force will create a shear force, and we'll call it as a primary shear force. That is P dash, we'll call it as a primary shear force. And the magnitude of this primary shear force is nothing but applied force divided by the number of rivets. That is one thing. So how it is going to act, that primary force, if I take the free body diagram of each rivet here, always if I apply a force in the vertically downward direction, then the reaction of the rivet should be as per our Newton's second law. Always the reaction force is opposite to the applied force. Here I am applying a vertically downward force, therefore the reaction of each rivet is going to be vertically upward. The reaction of each rivet is going to be vertically upward. So that's what I shown it here. So F1 dash, okay, maybe P1, P dash or F dash, you can take it. F dash or P dash, it doesn't matter. Okay, let us say it is F dash. So for first rivet, we'll take it as F1 dash. For second rivet, we'll take it as F2 dash. For third rivet, we'll take it as F3 dash. And for fourth rivet, we'll take it as F4 dash. See, now you can see that, yes, so this one is vertically upward. So for each rivet, this is your F2 dash, and here this is F4 dash, and this is your F3 dash. So that means because of this direct force, the force is divided by the number of rivets, and that much magnitude of the force is applied on all the rivets in the direction opposite to the applied force. Okay, so that means I am able to identify what is the effect of this direct force. Now I need to identify what is the effect of the twisting moment now. So here I am applying a twisting moment, something like this. So isn't it? So you have a force here, you have a eccentricity here. In which direction it is acting? So from the center of gravity, force into perpendicular distance P, it is going to act in the clockwise direction. So therefore here the moment is going to be in clockwise direction. But here the clockwise movement is created. So this is acting on this rivets. So because of this movement or twisting movement at the center of gravity of the riveting system, so these rivets are going to subjected to some shear forces. So such that the whatever twisting movement you are applying to the rivets here, that will taken by these rivets. That means an equal and opposite reaction will be created at these rivets. So to create an opposite direction, then so this is the distance of the center of the rivet from the center of gravity. So always your force is perpendicular to this, so that you will get the twisting moment here. So your direction of the twisting force will be something like this. If I join center of gravity to the center of the rivet, for all the rivets I need to do like that only. So I need to join center of gravity to the center of the rivet, then the force direction will be perpendicular to this, like this. For this rivet it will be like this. But in which direction here? See, this force, your applied force creating a twisting moment in clockwise direction, then the reaction of the rivet should be anti-clockwise direction. So therefore, so about this CG, if this rivet force create an anti-clockwise direction twisting moment, then it should act in this direction for this rivet. For this rivet it should act in this direction. For this rivet it should be the direction. For this rivet it should be in this direction. Or blindly, simply you can say it is thumb rule. So if it is clockwise, obviously the reaction is going to be the anti-clockwise direction. So all your arrows will be in the anti-clockwise direction. So you can see that the arrows are moving in the anti-clockwise direction. So that is one thing. So that means, so I have a primary force which is acting in the vertically upward direction for all the rivets. Then I have a secondary force which is also acting in the some direction, which is not perpendicular or parallel to the axis of rivet, but it is making some angle here. So that angle I can calculate here based on the configuration of this rivets. I can easily calculate that angle. So once I calculated that, that means this rivet, each rivet is subjected to two forces now. One primary force and another one is a secondary force. Now the next question comes is, what is the magnitude of that secondary shear force? So I want to estimate that also. So to estimate that secondary shear force, what we do is, again we need to apply the equilibrium equation. So here about this point, your twisting moment is F into E. F into E is going to be the twisting moment. So let us take the primary, the secondary force on the rivet one is something like F1 double dash is the primary force in this rivet, and then the distance of the okay, first I'll start from the first rivet here. So this is the first rivet, and the distance of center of the rivet to the center of gravity, I'll take it as R1 here. So then the force is acting in this direction. So that is this, I'll take it as F1 double dash. That is the secondary force will be represented by double dash, primary force by F dash. So now this is the one, and similarly for second rivet it is acting something like this. This is F2 double dash. So then I'll take the distance of center of rivet to the center of gravity of the rivet system as R2. Then if I come to rivet 3, this distance I'll take it as R3. Then if the force is acting in this direction, I'll take that magnitude is F2, F3, F3 double dash in the rivet 3, and similarly for rivet 4 the force is acting in this direction, and I'll take the magnitude of force is F4 double dash, and the distance, that is the distance of the rivet from the center of gravity to the center of the rivet, here it is R4. So now I want to estimate, just I have taken these forces as F1 double dash, F2 double dash and F3 double dash for F4 double dash. But what is our equilibrium equation here? Whatever may be the amount of twisting moment generated by these secondary shear forces, it should be equal to the applied twisting moment, that is Fe. That is going to be your equilibrium equation. So now first if I want to calculate what is the twisting moment of this F1 double dash, so what I'll get? F1 double dash, that is the force multiplied by the perpendicular distance. The perpendicular distance we are taking it as R1. Then for second rivet the force is F2 dash, F2 double dash, and the perpendicular distance is R2, plus for third rivet the force is F3 double dash, F3 double dash, and the distance is R3. Okay, I'll take it as R3, something like this. So for fourth rivet it is going to be F4 double dash into R4. So therefore this is the total twisting moment created by all the 4 rivets. Suppose instead of 4 I have some 5 rivets or 6 rivets or 10 rivets, something like this. Let us say n number of rivets. For all n number of rivets also I need to do the process something like this only. First I need to identify what is the magnitude of, what is the direction of the secondary shear force. So that direction is identified, just we need to draw the line perpendicular to the line joining center of rivet to the center of gravity. So therefore this line is perpendicular. So that means this angle is 90 degrees, this is 90 degrees, this is 90 degrees, even this is also 90 degrees. So now I got this line. So then based on whether the applied twisting moment is in clockwise direction, then your arrow direction is going to be the anti-clockwise direction. So like that I'll identify the direction. Once I identify the distances and direction of the forces, now I'll try to find out what is the total twisting moment generated by, or the reaction twisting moment generated by these all 4 rivets, or maybe the n number of rivets. I'll sum that. So for equilibrium, this twisting moment should be equal to the applied twisting moment. Okay, so this is equilibrium equation, but I have only one equilibrium equation, but how many unknowns are there for me? I don't know what is F1 double dash, F2 double dash, F3 double dash, F4 double dash. That means if a 4 rivet system is there, I have 4 unknown forces. So one equation, 4 unknowns, I cannot solve for 4 unknowns with a single equation. I need 3 more additional equations, then only I can solve it. So, or else I need how I can get the additional 3 equations here. Without, if I don't get the additional equations, I cannot solve this. Similarly, if I have n number of rivets, I have n number of unknown forces. In all n number of rivets, I need to calculate what is the secondary shear force. So those n number of forces are also unknown. So therefore, in that case, I require n number of equations. So, but from the equilibrium here, I got only one equation here. So, therefore, what we'll do is, so in order to solve this equation, we'll make some assumption here. So, with that assumption only, we can solve it. Otherwise, it is not possible to solve this equation because you have 4 unknowns and one equation. It is impossible to solve for 4 unknowns with a single equation. So, that's why what we are doing is we are making some assumptions here. So what are those assumptions here? So whatever may be the magnitude of these forces, secondary shear forces in each rivet, I'll take those are proportional to the distance of the rivet center from the center of gravity. So that means your F1 double dash is proportional to R1. Similarly, F2 double dash, that is proportional to R2, and so on. F3 double dash is proportional to R3. F3 double dash, F4 double dash is proportional to R4, and so on, so on, so on. Fn double dash is proportional to Rn value. So, and also if I assume something like that, so then this whatever may be the proportionality constant is there, I'll fix that one as some C. Let us say F1 double dash, if I remove that proportionality symbol, I can write F1 dash as some constant C into R1. Then your F2 double dash is also again what I'll do is, so the proportionality constant is same for all the rivets. C R2, CR2. Similarly, F3 double dash is nothing but C into R3. Like that, I can generate the required number of equations now. So here this is one equation, 4 unknowns. So now with these things, I have, if I write the fourth equation, that is your F4 double dash is equal to C into R4. So now this is one equation, two equations, three equations, four equations, and this one is fifth equation. Now I have 5 equations. But how many unknowns are there? I have 5 unknowns here. Your F1 dash, F2 dash, F3 dash, and F4 dash. In addition to that, you have one more unknown here. C is also there. So total 5 unknowns and 5 equations. Now I can solve for this unknown forces, F1 double dash, F2 double dash, F3 double dash, and F4 double dash. So let us take that these 4 rivets condition now. How I can estimate these values now. So now if I use these conditions now, what I do is, so from this equation I can write an expression for C. What is C now from this? I can write this one as F1 double dash. F1 double dash divided by R1 is equal to C. Or similarly, from these 4 equations, I can write C is equal to F1 double dash by R1. So this is from the first equation. If I take the second equation, from the second equation also what I can write is same C is equal to F2 double dash by R2. Then if I take the third equation, your F3 double dash is equal to C into R3. From that also I can write same C is equal to F3 double dash divided by your R3. I'll write it here, R3. So like that I can write it. So but if I use these two relations here, these two are equal. So because both are equating to C, we are equating F1 double dash by R1 is equal to F2 double dash by R2. So that means, so from this I can generate any number of equations. F1 double dash by R1 is equal to F2 double dash by R2. So this is equal to C only. This is equal to C. C equal to F1 double dash by R1, F2 double dash by R2, F3 double dash by R3, and which is also equal to F4 double dash by R4. Now I have here, these are the 4 equations. So from these 2 equations, I can identify a relation between F1 double dash and F2 double dash. What is that relation here? If I use these 2 equations, from these 2 equations, I can write F2 double dash as, so for this I need to bring this R2 to this side. So it is going to be your F1 double dash by R1 into R2. So this is your C only, C into R2. Here only we write it like that. F1 double dash is equal to C into R1, F2 double dash is equal to C into R2. Your C is only this F1 by R1. So that means your F2 is this F1 by R1 into R2. Similarly, our F2 double dash is also C into R2, like that. Now I am able to find out the C value here. If I substitute that, I know all these forces. But what I am doing here is, I am substituting this F2 double dash, F3 double dash and F4 double dash in terms of only F1 double dash. So now, if I do that, in this entire equation, I have only one unknown, that is F1 double dash. So, one equation, one unknown. Now I can solve this equation. If I solve that, so what I'll get? Maybe I given that expression here. See here, something like this. Okay, he has taken the distances as C1, C2, C3. We are taking it as R1, R2, R3 only. So finally, if you take that, you are going to get your expression for C is something F into E by C1 square, C2 square, C3 square, C4 square. So I got C value. Once I got the C value, just like I written the values, F1 double dash is nothing but C1 into R1 or C1 into C1 here. So F2 double dash is C into C2, F3 double dash is C into C3, F4 double dash into C into C4. I'll get all these forces now. Once I know these forces, then I need to find out what is this inclination also. So now I know everything now. I know the magnitude of this force, secondary force, and magnitude. Here I shown it here. What I'll do is, I will take a zoom of it so that you can clearly see that here. I can enlarge this. Okay, so now you can, maybe I think it is now maybe somewhat clear or visible to you. See now here, for each rivet, what I have here is, okay, I don't have a pen provision. If I go for, okay, or else I'll zoom it and, okay, in this I'll do it, zoom it. Yeah, okay, here also I can do this, I think. Yes, I can zoom it. Okay, now you can see here, I have, so for each rivet, now I represent the primary force and secondary force. See, okay, I take the pen here. Okay. Now I zoom it. In zoom mode, okay, anyway, the pen is not coming. So pen provision is not there. Okay, no problem. Here, see, you can see that here, this is the, okay, if we take first rivet here, so this is the primary force and this is the direction of the secondary force. So now I have two forces acting at this first rivet. Similarly, for second rivet also, this is the primary force and this is the secondary force. For third rivet also, this is the primary force and this is the secondary force. For fourth rivet, this is the primary force and this is the secondary force. Now, two forces are acting at some inclination now. So here, this inclination I can calculate it, I can easily calculate it, provided if I know this dimension, this center distance to this point, and these dimensions, if the riveting dimensions are given, I can easily calculate what is this angle. If I know this angle, so since two forces are acting here with some angle, I can find out its resultant force also. I can find the resultant force also. If I am able to find out the resultant force, so that means since I have two shear forces which are acting in different directions, I am able to find its resultant. So once I know the resultant force, so because of that resultant shear force, I need to calculate what is the resultant shear stress. So then I'll take that resultant shear stress and I'll equate that one to the allowable shear stress. From that I'll get the diameter of the rivet. But the thing here is, so in which rivet I need to consider that force. That means here I have 4 rivets. Maybe in some other example, we may have 7 rivets or 8 rivets or something like this, n number of rivets. So to determine the diameter of the rivet, which rivet I need to consider. So based on which rivet I need to design, or I need to find the diameter of the rivet. So for that, what you have to do is, so one thing is, if you don't know the fundamentals or principles, anything is, what you can say, a rude way of solving that problem is, first you need to find out the resultant forces for all the rivets. That is, what is the resultant force on rivet 1, rivet 2, rivet 3, rivet 4. Then out of all those 4 values you calculated, you have to take the maximum values corresponding to which rivet. So that means you need to design for again the maximum value here. So that means let us say the force is F1 is in the first rivet, F2 is in the second rivet, F3 in the fourth rivet, third rivet, F4 is the fourth rivet. So out of these 3, F3 is maximum. So therefore then you need to design the or you need to find the diameter of the rivet based on F3 only, not the least forces values. You need to design the rivet for the highest value of these forces. So I'll get that value. So once I take in the highest value, then that is the force which is the rivets are subjected to. Then 5 by 4 d square is nothing but the shearing area of the rivet. So load divided by the shearing area, I'll get the shearing stress in the rivet. So which should be equal to the allowable stress. So in that only the d is unknown to me, and then I can solve for the diameter of the rivet. So but the thing here is, if sometimes if the angle is 90 degrees, it's okay. Straight away I can easily calculate it. But here, most of the cases you may have angle is either more than 90 degrees or less than 90 degrees. If they are 90 degrees, then fx square plus fy square. Resultant force is nothing but square root of your fx square plus fy square. But in most of the cases, you will get either the angle is more than 90 degrees. Here, if you take this one, here the angle is more than 90 degrees. Here it is less than 90 degrees. Here more than 90. Here less than 90. So if that is the case, then you need to use your cosine formula. So here to compute the resultant force, so you need to use this formula. So that is F1 dash. Maybe here it is wrong. It is square also there. F1 dash square plus F2 dash square plus 2 F1 dash F2 double dash cos theta, where cos theta is the angle between the primary force and the secondary force. This will take it as theta. Either you can take this one as theta, or else if I take like something like this, so or else in this one is the your theta. So theta 1 here. So here this is theta 2. Here this is your theta 3, theta 4 here. This is third rivet, theta 3, and this is the second rivet, theta 2. So like this, you need to compute theta 1, theta 2, theta 3, theta 4 for all the things. Then you need to use this formula to find out the resultant force. Once I know the resultant force, then I can pick the maximum value from the all the available values. Then I will find the diameter of the rivet based on that maximum value only. So, so one way of doing that, okay, so that is fine. One way of, that is like I said, it is a rude way of finding out. So that means, so without applying any concept or any principle here, blindly I am calculating the forces, and theta, first I will calculate theta values for all the things. Then I will find out the resultant force in all the rivets. Then I will pick the maximum value. But instead of doing like that, so that means suppose here 4 rivets, then it's okay. You need to compute only 4 forces. Suppose if I have 10 rivets in the system, then you need to compute theta value for all 10 rivets. Then you need to apply this formula to compute what is FR for all the 10 rivets. Then you have to pick the maximum value. So that is going to be a somewhat tedious process. So now here, to avoid that, here what we can say is, if you look at this expression for FR here. So if you look at FR here, so it is F1 double dot square, F dash square and F1 double dot square plus 2 F1 F double dash F1 dash F1 double dash cos theta if I take first rivet. So in this case, suppose here if cos theta is more than 90 degrees, then what happens to the cos theta value? If theta is more than 90 degrees, what happened to the cos theta value? Is it going to be negative or positive? So more than 90 means it is in second quadrant. In second quadrant, cos is negative or positive? You don't know? Shivaprasad, roll number 13.
Sir.
Are you there? Okay, so you know that if theta is more than 90 degrees or if theta is in the second quadrant, cos theta will become negative or positive?
Positive.
Positive.
Negative, sir.
Negative.
Yes, sir.
Greater
than 90, less than 180 అయితే నెగిటివ్ సార్.
దీన్ని అడగలేదు గారు, నేను శివప్రసాద్ గారు అడిగింది. ఒరే మీ ఇంటర్మీడియట్ లో చదువుకొని ఉంటారు కదా, ఏదో ఫార్ములా చెప్తారు ఆల్ సిల్వర్ టీ కప్స్ అని.
మామూలుగా ప్లస్
ఆ.
మైనస్ ప్లస్ మైనస్ అవి తెలుసు సార్ ఈ కాస్ట్ అవి గుర్తులేదు.
ఏంటి
ఫస్ట్ క్వార్టర్ అయితే ప్లస్
ఏంటి ప్లస్ ప్లస్
అదే అలాగే చెప్పారు సార్ ఈ
ఏం
గుర్తులేదు.
చెప్పారు అదే చెప్పు, నాకు అర్థం కాలేదు నువ్వు చెప్పింది ఏం చెప్పారు నువ్వు. ఫస్ట్ క్వార్టర్ అంటే ప్లస్ ప్లస్ అంటే ఏంటి ప్లస్ ప్లస్, ఏది ప్లస్ అంటున్నా. ప్లస్ అన్నావు, దేని ప్లస్ అది?
యాక్సిస్ ప్లస్ సార్.
అరే అది వై యాక్సిస్ ఎక్స్ యాక్సిస్ గురించి చెప్పట్లేదు నేను ఇక్కడ. ఇది ట్రిగ్నామెట్రిక్ రిలేషన్స్ కదా నేను అడిగింది. మళ్ళీ ఎక్స్ యాక్సిస్ వై యాక్సిస్ అని ఎక్స్ యాక్సిస్ వై యాక్సిస్ ఓకే. కోఆర్డినేట్ ఫస్ట్ క్వార్టర్ అంటే బోత్ ఎక్స్ వై పాజిటివ్, సెకండ్ క్వార్టర్ అయితే ఎక్స్ నెగిటివ్ వై పాజిటివ్, అదే చెప్తుంది నువ్వు. అది కాదగా అడిగింది నేను. కాస్ థీటా వాల్యూ పాజిటివా నెగిటివా సెకండ్ క్వాడ్రంట్ లో ఉందంటే. సో యాంగిల్ ఉందిరా 360 డిగ్రీస్ యాంగిల్ రా మనకి. ఒక సర్కిల్ ఏదైనా 360 డిగ్రీస్ ఉంటే 0 to 360 డిగ్రీస్ ని 4 పార్ట్స్ కి డివైడ్ చేస్తే దాన్ని 4 క్వాడ్రంట్స్ అంటాం. ఫస్ట్ క్వాడ్రంట్ ఈజ్ 0 to 90 డిగ్రీస్. సెకండ్ క్వాడ్రంట్ ఈజ్ 90 to 180 డిగ్రీస్. థర్డ్ క్వాడ్రంట్ ఈజ్ 180 to 270 డిగ్రీస్. Fourth quadrant is 270 to 0. So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So that 360 is divided into four quantities. So 1/4 ne quadrant antam anamata. 4 parts ne quadrants antam anamata. So ఇప్పుడు 0 to 90 ఉంటే దాని ఫస్ట్ క్వాడ్రంట్ అన్నాం, 90 to 180 లో ఉంటే దాని సెకండ్ అన్నాం, 180 to 270 అంటే దాని థర్డ్ క్వాడ్రంట్ అన్నాం, 270 to 360 ఆర్ 0. ఎందుకంటే ఈ సర్కిల్ కదా మళ్ళీ అదే అక్కడికే వస్తుందిగా. 360 అంటే 0తో స్టార్ట్ అయ్యి మళ్ళీ 0 కాడికే వస్తుంది 360 అంటే, అందుకని దీన్ని 0 అనే తీసుకుందాం. సో ఇప్పుడు నాకు ఈ క్వాడ్రంట్ లో ఉందనుకో థీటా వాల్యూ. సో ఇది ఇందాక రాశాక నేను ఏ ఆల్ సిల్వర్ టీ కప్స్. సో ఏ ఫర్ ఆల్ మీన్స్ సో థీటా వాల్యూ ఫస్ట్ క్వాడ్రంట్ లో ఉంటే నువ్వు ఏదైనా పాజిటివే, సైన్ అయినా కాస్ అయినా టాన్ అయినా ఆల్ ఆర్ పాజిటివ్ ఇయర్. So only sin is positive in the second quadrant, only tan is positive in the third quadrant, only cos is positive in the fourth quadrant. Okay, so now we don't bother about all these four, we will bother about only. So if theta is less than 90, no issue. So we know that all are positive, whether cos theta or sin theta is going to be negative. But here if cos theta is more than theta is more than 90, so that means if theta lies in the second quadrant, see you can see that here it is more than 90 in this case, even in this case also it is more than 90. So these two instances, here these are less than 90 only. So now what I want to say is if theta is in the second quadrant, your cos theta will become negative. If cos theta is negative, then what happened to this quantity? This plus symbol will be replaced by minus now, because your cos theta is if cos theta is in second quadrant, I can write cos theta or cos 90 plus theta. How I can write this one? This is in case of second, if theta lies in second quadrant, I can write like this, which is nothing but 180 minus theta I need to write. So okay, anyway, so here if theta is between 0 to 90, here this will become a negative quantity, means so if you calculate FR, what you are going to get is F1 dash double square and F1 double dash square minus 2 F1 double dash cos theta. I will get something like this. So in that case, what is going to happen here is it is going to be negative quantity, means your resultant force is going to be decreased. If it is plus, you will get more value. If it is minus, you are going to get the lesser value for this. That means, so one thing what you need to do, by looking at this diagram, this loads only, directly you can say that the force in these two rivets is more than the force in these two. So that means I don't need to calculate the forces in these two, because obviously the forces in these two are going to be less when compared to these two. So therefore either F2 or F4 is going to be the design criteria. So therefore again for these two rivets only I will calculate the theta value. If they are same, then I can calculate only for one rivet, I can calculate it. So then from that I can easily calculate the resultant force, which we need to consider for the designing of the rivets. So like that. So only thing is, so if you don't know that concept, what you have to do is you have to estimate for all the rivets, you need to estimate what is the resultant force. Then out of that you need to pick the maximum value and you can design the rivets based on that. Or before the, if you don't want to use that approach, what you have to do is you need to look at the values of theta where it is minimum. Why I said it is minimum? Suppose if theta is 0, what is the value of cos theta? It is 1. So that means these two f1 dash, f1 double dash cos theta will have maximum when theta is equal to 0 only. So when theta is equal to 90 degrees, then what happens? This is going to be 0 only. If it is more than 90, it will become negative. So that means, so always your maximum resultant force will occur when theta is less than or close to 0. If theta value is, which is the nearest value to the 0. If you have here, if you take this rivet system here, you have 4 rivets. For all these 4 rivets, you need to identify that which rivet is having a theta value which is close to or which is the nearest one to the 0. So then based on that only we are going to design the joint. Right? So like this, I can find the, or I can identify the, what I can say, that is the force which is having going to be the maximum value, or rivet which is subjected to the maximum resultant force. So then I have to design the joint for based on that rivet only, not all the rivets. Okay, so like this we can solve the problems when a riveting joint or riveted joint is subjected to eccentric force or eccentric load. So only thing what you need to do is first step what you have to do is first you have to identify. So while solving the problem, what you need to do is you need to identify the what is the center of gravity of the rivets. That is also you need to calculate. So here, since it is a simple one, so if you have a symmetry, so here it is symmetric. So therefore, obviously the symmetry about x-axis as well as y-axis, the intersection of x-axis and y-axis is going to be OCG. But that is not the case in all the joints. So first you need to compute what is the center of gravity of the rivet. So that means you need to identify this G also first. So for that you have to use your mechanics formula. So what is your x bar and y bar formula? Your x bar is nothing but a1 x1 plus a2 x2 plus a3 x3 plus so on divided by a1 plus a2 plus a3 plus a4, something like that, right? That is your x bar formula. Similarly, y bar formula is, so the center of gravity means it is a plane problem, so you have only x bar and y bar. So if it is a space problem, you will get z bar also, but here it is a plane problem only, so we will consider only x bar and y bar. X bar is nothing but, so if I take the area of the rivet is A1, rivet 1 is A1 and rivet 2 is A2 and rivet 3, okay, maybe that I have that diagram also here. Where it is? Oh, it's gone, it's not there. Okay, maybe that slide is gone. Oh, where is? Okay, it is there, yes. Okay, yeah. So these are the formulas to compute the center of gravity of the rivet system. Let us say I have a rivet located something like this. I have 5 rivets, something like this. So A1, area of the first rivet is A1, area of the second rivet is A2, area of the third rivet is A3, fourth rivet is A4, fifth rivet is A5. So then I want to identify what is the G value, that is center of gravity of this rivet system. For that, what I need to do is somewhere I have to fix the origin. So our reference axis, what I can say is instead of origin, I need to fix the reference coordinate system. So let us say I fix the reference coordinate system here. So in that case, so if this is the G, so this is your x bar and this is the y bar. What is the formula for that x bar? Sigma ai xi divided by sigma ai. And similarly, y bar is sigma ai yi by sigma ai. So, but here, since we are using a rivet system here, we'll assume that all the rivets are having same cross-sectional area. Means the diameter of all the rivets is same. By assuming the diameter of all the rivets is same, now if that is the case, if the diameter of all the rivets is same, then your A1 equal to A2 equal to A3 equal to A4 equal to A5 equal to A only. So now if I apply that formula here, your AI and AI will cancel out each other, then what you are going to get usually is x bar is nothing but x1 plus x2 plus x3 plus x4 by sigma, your number of rivets only. Sigma A, in place of sigma AI, what you will get is, you will get the number of rivets. So that means sigma xi divided by n. Similarly, your y bar is sigma yi divided by n. So that means simply I need to count how many number of rivets are there. Then I need to identify what is the distance of this rivet from the origin. What is the x distance? So this is the x distance. So that means with respect to y-axis, how much distance it is there? It is x1. Similarly, this is going to be the y1. So like that, first I need to identify what is x1, y1, x2, y2, x3, y3, like that. For all the rivets, I need to identify what are the x coordinate and what is the y coordinate. Once I identify that, then your x bar is nothing but sigma xi. So that means sigma xi means x1 plus x2 plus x3 plus so on up to xn divided by the number of rivets. Similarly, our y bar is nothing but sigma yi divided by number of rivets. So with this, I can easily identify the location of the center of gravity. After identifying the center of gravity, then you need to find out what is the distance between the center of gravity to the rivet centers. So for first one, for second one, I need to join the centers of rivets to the CG first, like this. So then I need to identify what is this distance. Let us say this is R1, this is R2, this is R3, this is R4, and this is R5. Like this, I need to find the distances. All the distances are the distance of the rivet centers to the center of gravity. Then you need to draw the perpendicular lines here. For all these lines, you need to draw the perpendiculars here. Then, based on your movement direction, you need to take the direction of your secondary shear force. So, something like this. If it is your movement is in clockwise, applied movement is in clockwise, so your reaction is going to be anti-clockwise. All these arrows will rotate in anti-clockwise direction. So, once I know that, so I can, whatever relations just now we discussed, using those relations, these equations, you can easily calculate the secondary shear forces. Primary shear forces are nothing but which is same for all the rivets or which is equal for all the rivets, which is nothing but applied load divided by the number of rivets only. So then I got the primary force and secondary force for each rivet. Then I can find out the resultant force. So once I have a resultant force, now your FR by shearing area of the rivet, that is nothing but 5 by 4 d square. Of course, here this is FR. It should be equal to your tau allowable. So this will be given to you in the problem. This you are computed. So then only unknown is D. So now from this equation, I can find the diameter of the rivet. That's it. So that's how you can solve the problems when a riveted joint is subjected to eccentric loading. Okay. So I think I'll stop now. Maybe in next class we'll try to take up some problems on this eccentrically riveted, loaded riveted joints. Not only this, you may come across these kind of problems even in the next unit also. You have a bolted connections are there or bolted joints are there. Even bolted joints is also subjected to eccentric loading cases there. So even in that case also we are going to deal with the problem in the same procedure, same manner. Only thing is, here this rivet diameter is replaced by the bolt diameter. That is the only thing. They will ask there, find out what is the bolt diameter. So, but the same bracket, now instead of a plate, now I'll take this is a wall. To the wall, this bracket is fitted through some bolts here. So now this is what I call it as a bolted joint. So because it is connected through bolts. So now what is the diameter of the bolt required? Or minimum diameter of the bolt? You need to ask, calculate what is the minimum required diameter for the bolt because of, let us say if this F is some 50 kilonewtons. If I apply some 50 kilonewtons force here, what is the minimum required diameter for the bolt? So like that they will ask. So whether it is riveted joint or bolted joint, the approach is same. The procedure is also same. So that means if you understand the principle here, the same thing we'll use in the bolted joints also. In the examination point of view, in the examination point of view also, either you may get definitely you will get one problem on eccentric loading. If you get a problem on this, on the riveted joint eccentric loading, you won't get on the bolted joint. Or if you get a problem on bolted joint, you won't get it here. Maybe a different problem you will get, not on this eccentrically loaded joint. So something like it is there. That means if you understand that clearly here, it may be useful here in case of bolted joints also. Okay, right. So now I'll stop now. So suppose if you have any questions or any doubts in this, so for whatever we discussed, then you can ask now. So that we can discuss your doubts also. So otherwise, if it is clear or everybody say that okay, I am very well understood all these concepts, then you can leave it. So just respond to the attendance sheet and then you can leave the class. Okay. So now if you have any question, then now you can ask. I think already attendance sheet is there. So already 60 members has given the attendance. Okay, you are I don't know whether you are following the class or you are giving the attendance. Okay, anyway, so here 59 are given the attendance, but in the class only 53 members are there. So what happened to the remaining 6 members? I don't know. Just for the sake of attendance, just you joined it and then you left the class. Maybe that roll number 38 he was there. Okay, definitely he won't be there. But if I look at the attendance sheet, okay, in absentees his number is not going to be there. See, 38 is not there in this. Okay, and so that means he is present in the list. In the presented list, he was there. 38, 338. Here it is here. Okay, but now he is not there in the class here. So how it is going to happen, I don't know. So by randomly, directly I said 38 is not going to be there in the class, and you will give the attendance, something like that. So what is the benefit you are going to get if you do like this? If you want attendance, then I'll give the attendance. It is not an issue at all. But my intention is you want to attend the class, then you need to follow the class. If you are not doing that, then it is a useless thing. So just for the sake of attendance, you are joining the class and then you are leaving means it is a useless thing. And not only that, I think somebody is doing proxy for him also. Maybe even he is not joining the class at all. Somebody is doing proxy. So then if I ask now 38, then he will SMS through WhatsApp to that fellow and sir is asking about you, then come to the online like that, he will say. Then you will come and join the class. So what you are going to get with all these things? Useless things. Okay, anyway, so that is left to you only, whatever practice you are going to follow. If you are going to follow practice or for the attendance, sake of the attendance, that is also, that point is also I am leaving to you. So I don't bother about all those things. Okay, right. So, okay. So now you tell me you have any doubt, then we'll discuss. Otherwise, I'll close the class.